Okay, welcome back to our next maths lesson. And today we're going to continue thinking about fractions and how those fractions and our knowledge now of mixed numbers alongside fractions and improper fractions can help us understand sequences of numbers. Because when we sequence numbers and we think about fractions within those sequences, we need to use our knowledge of mixed numbers to help us. So the first thing I'm going to ask you to do is have a look at these three questions. And I just want you to have a think about them, because some of them are to do with the key vocab that we're thinking about. So have a go. If you're not sure, don't worry, we will go through them. Pause now. Okay, so the first question says, how many terms are shown in this sequence? So first, there's two words here. There's terms and sequence. Sequence is just a line of numbers, basically. And what we're thinking about, that they're related in some way. Terms mean how many numbers are we seeing within that sequence. So in this case, that's 5 terms. 1, 2, 3, 4, 5. Then we talk about a rule for a sequence. So I told you that all the numbers in a sequence are related in some way. So the rule is the way that they're related. So what's the relationship between these 3 terms in our sequence? Well, the relationship is that you're minusing 16 each time. And that would then be the rule. So every single number in that sequence would have to follow that rule. And the next one here is, what's the next consecutive integer after 19? There's 2 words we need to think about: consecutive and integer. Consecutive just means next, the one after the one you're looking at. Integer means whole number. So what is the next consecutive integer after 19? Well, it would be 20. Integers mean whole numbers, and that's really important that we remember that. Okay, so here's a sequence. We've got 2 terms so far. We know we're going to keep going. What's our relationship between our first and our second term? What's happened between the 2 of them? Well, we've added a quarter. So that would mean that each jump is then also going to be adding a quarter, because that's our rule. Then we can actually carry that forward and answer the questions. So 1 and 2 quarters, I add another quarter on, so I can just colour that one in. And I get 1, full 1, and 3 quarters. 1, full 1, and 3 quarters. The next one, I can colour in the next one, and that gives me all of them. So it'd be 1, full 1, and 4 quarters, or we know that 4 quarters is the same as 1, so altogether that's 2 whole ones. And then our final one, we add another quarter on. We have to start a new bar, add the quarter in, and we get 2 and a quarter. And you can see our relationship between them. Now there's one other thing we can do, and that's called simplifying, which means we change a fraction to the simplest form it can take. And that is because this here is the same as if I just split it in half. That would be half of a bar. So that 2 quarters is the same as a half, and we could write it like that as well. Now you would still get the mark normally for either way round, unless it specifically asks you to simplify it, which is to find the simplest possible fraction. Here's our next one. And we might struggle here to think about what we're doing in order to get between the numbers. Well, we know that we're adding 1 between this one and this one. And we have 1, 2, 3 steps in between, which implies each jump must be what? Now there's a hint. Think about this. Yes, you're right. Each jump is adding a third. So in the case from 1 and 2/3, we come to 2 whole ones, then we add another third, and finally another third to make 3 wholes, and then 3 and 2/3. And you can see the pattern continues up. And it's like counting, except when you get to a fraction that means you get another whole, you just start the next integer. Okay, so have a look at this one. What do you see is going on? What's the rule? Well, the rule and the difference between these two is 2/9 from 5 to 7. So we would have to continue that rule. So add 2 ninths, and keep going. Have a think about how it would go. So that's the rest of our sequence filled in. Now, what we also know is that we can relate some of these to whole numbers down here. So we have to do that as we go along. Now, this is why it links nicely into what we were doing before about our mixed numbers, because you have to think about how many we have. But the easiest way to actually do this is to continue along the bottom and work it that way. So 1 and 2 ninths, then you get 1 and 4 ninths, 1 and 6 ninths, 1 and 8 ninths. You can see you're adding 2 again. Now, the next one is an interesting one, because 18 ninths would be 2, but we're adding 2, or 9 ninths would be 2. We're adding an additional 1. So actually, it would be 2, 1 and 10 ninths, but we know that 9 of those 10 ninths is another 1 whole. So it actually becomes 2 and 1 ninth. And this is where our knowledge of fractions, our knowledge of mixed numbers and improper fractions really can help us when we work through a sequence like this. As long as you remember all our rules, if we needed to write it out, we could. I mean, what you could do, if you know you're working in ninths, you could draw a bar, split it into 9. One, 2, 3, 4, 5, 6, 7, 8. Almost there, 9. And you go, okay, the first time I'm starting on 5. So 1, 2, 3, 4, 5. Then it says adding 2 ninths. So 2 ninths, that's 7. Another 2 ninths, that's a whole one. Then I draw my next bar. So you can use visual representations in order to help you understand this. Got to that, fill in another 2. That's 1 whole 1 and 2, a whole 1 and 4, whole 1 and 6, whole 1 and 8. Then I have to add another one. And this is that tricky part that would be if we were just working with our numbers. But if we're working with pictorial representation, we go 1, 2, 2 full ones and 1 ninth. And you can see it straight away. So now it's your turn. Have a go at these questions. You can use pictorial representations to help you if you like. Remember, find the rule and continue. Pause now and have a go. Okay, so let's have a look at the answers. We're going to split this into 2 sections. We're going to do 1 and 2 first, and we'll look at 3. So number 1 hopefully is nice and straightforward because they've got part of the pictorial representation. So you're just showing the next step or the missing ones in order to show the differences. You find out what the rule is. So the jumps on this one, that jump from 1 to there was 1/5. So you're adding a 5th all the time. The jump from there to there was 2/5. So we're adding 2/5 all the time. And that should always be your first step. What is the rule? What's the jump that we're having to make? So let's think about that in terms of number 2. Number 2, the difference between this one and this one, we go like this. That's only 1/7. So each jump should be 1/7. So 4, 5, 6, 7 sevenths, 8 sevenths, 9 sevenths. We can fill the improper fraction bit along the top. Then we're looking at the mixed number one on the bottom. 4, 6, 5, 7, 6 sevenths. 7 sevenths is the same as 1, so we've already got that filled in for us. Lucky us. 8 sevenths is the same as 1 and 1/7. Then we just add 1 on 1 and 2 sevenths. Same goes on here. What are we doing between these two? Well, we're adding 3 sevenths, aren't we? So 3 sevenths each time. Keep adding 3 sevenths. You can see the number increases on the numerator increases by 3 each time. And then on the bottom, you follow along. And in this one, drawing it might help just to get the relationship between these two. And you can fill them in as you go along. So you go, you've got 2, you've got 7s. I've got 6 sevenths. That's 1 more to get to 3, then 2 more after that to get 2 sevenths. And that's how you would look at it. You kind of almost bridge through it. You add 1 seventh, that gets you to 3, then you add the further 2 sevenths to get you to that. And in total, that 1 seventh and that 2 seventh equal the 3 sevenths you're adding in. Then our final one, what's happening between these two here? Well, we don't know that because this number's not there. So we have to go all the way down to here and work between two numbers that we do know. So what's our relationship between 15 and 12? Well, we're taking away some amount of eighths. And how much are we taking away? 3/8. So we go back and fill in, taking away 3/8 each time. And the same happens on the bottom with our mixed numbers. Now, again, you can do this, for example, using a var method. So you just do it in reverse almost. So we're going to go to 3 first. I'm splitting them into eighths because I know I'm counting in eighths. So like that. I've got all of them. So it doesn't matter. I don't need to colour them in. What I'm going to do is cross them out. So I'm going from 3/8. That's 24. I've got that there. I'm taking 3 away. So 1, 2, 3. How many am I left with? I'm left with 2 whole ones and 5/8. Take away another 3. 1, 2, 3. 2 whole ones. And it says 1/4. This could also be written here as 2 and 2/8. These ones here are simplified, and that's why they come out as this. That would be 2 and 2/8 like this, but 2/8 is the same as 1/4. And in this case here, if we take away another 3, 1, 2, 3 gets us 1 and 7/8. 1, 2, 3. That's 1 whole 1 and a half, because you can see that that would be the same as a half. 4 on this side, 4 on that side. So it's 1 and a half, or 1 and 4/8, or 1 and 2/4, or 1 and a half. All of these are the same because of our equivalent fractions, which we were thinking about last week. So question 3 was continuing the sequence, and this works exactly the same way. If you wanted to, you could draw out your pictorial representation, or you can draw out a number line in order to help you. But again, all you're doing is trying to find the relationship between the two parts. So what's the jump that's happening here? Well, I need 1/8 to get to 3 and additional 8, so it must be 2/8 I'm adding on each time. Keep that up and keep adding them on. This one here, what's the relationship between this one and this one? Well, I go from 5 and 6/7 to 5 and 3/7, so I must be taking away 3/7 each time. And I work my way down. And the last one here, I'm going from 6/11 to 3/11, so I must be minusing 3/11. And you can keep that trend up as you go down. What is the same and different about the sequences in parts A, B, and C in Talk with Your Partner? The difference is that we're taking away here. And no number lines. Okay, so have a look at this one. What do you notice? So the difference is 4/11. So, but we're taking away. So we go down 4/11 to get to 8/11. And the difficulty is, how do we show this? And there are lots of different ways to look at it, but you can bridge through the number through 6. So like I said before, one way to do it would be, okay, so I've got 1/11, so I'm going to have to minus 11 to get to 6 to begin with. Then I still need to take away, I've taken away 1, I need to take away the further 3, and that gets me down to 8/11. So you're kind of going through the integer in order to get your next number, or you could use diagram. See what you can do. Try it yourself. Okay, so the next one is 5, because 4/11 take away 4/11, 5 and 4/11 take away 4/11 just leaves you with the 5, nice and easy, and then we go down from that. We talked about the rule subtracting 4/11. Here's our next one. There are 3 boxes, so the missing factors are thirds. That's what the minion thinks. What do you think? Is he right or is he wrong? Well, unlucky for the minion, he's wrong. The first and the fourth terms are consecutive integers, 10 and 11. There's 4 jumps between them. And it's the jumps which are massively important, not the amount in between them, not the number of parts in between them, the amount of jumps. You go 1, 2, 3, 4. So 4 jumps being your total 1. 1 divided by 4 is a quarter. So each jump is a quarter. So that means each of these steps, I'm taking away a quarter. And that's our rule for our sequence. And there you have it. Okay? When you're thinking like this, what you do is you think about where your number is. So 11 and 10. And how many jumps there are in between. So in this case, we've got 1 jump, 2 jumps, 3 jumps. 3 jumps between it would be 1 divided by 3. 1 divided by 3 is a third. So each jump would be a third. And that's the way to think about it. If I had 11 and 5 in the middle here, missing numbers, and then there's a 10. How many jumps and what do you think each jump would be worth? Well, let's have a look. We go 1, 2, 3, 4, 5, 6. 6 jumps, and we're dividing 1 by 6. So 1/6. And that's the way to remember it. So now it's your turn. Have a go at these questions for me. Pause now and have a go. And here's our answers. The first one is just matching the rule. So you look between the two of them. Well, this goes from 4 to 2/3. That would be my easy one. So I'm adding 2/3. Here, go from 4 to 4, 4 3/4. And recognize what I'm doing. I'm looking at the integer and working out the next one in the pattern. That gets me easily there. So that's adding 3/4. Here, I look at my integer. That's 3. Look there. But the next number actually is lower. So I'm subtracting. I know I'm subtracting. So I look at the number before it and see how much I'm taking away. 2/3. This one, I don't have an integer. So it does make it harder because of that. So what you have to do is you have to look, and I would normally look between 2, if you've got them, 2 with the same whole number. So this 3 would be the one I look at. What's the difference between this and this? It'd be 2/4, and 2/4 is the same as 1/2. That's this one. Also, just so you know, you've already linked all of these ones. You're only left with one left. Makes your life easier. Next one said Teddy and Rosie are finding missing numbers in a sequence. We've got 3 here and 4 here. We've got 1, 2, 3, 4, 5, 6, 7 missing numbers. So I think the missing fractions are sevenths because there are 7 blank cards. Is he right or is he wrong? Well, he's wrong because we talked this through before. There might be 7 missing things, but actually, how many jumps are there? Well, there's 1, 2, 3, 4, 5, 6, 7, 8 jumps, which means he's actually going to be counting in eighths. And you could argue that either way. That's the way I would argue it, not arguing it the way it's written down there. Oops, sorry. I was just going to move myself out of the way. There we go. And so complete it. So in eighths, there it is written in eighths, nice and easy. And then this girl here is stating that she thinks that one of the missing one of the missing fractions is equivalent to 3.5. Well, we are going through all of them, so the answer is definitely going to be yes. And the one is that 4/8 is the same as 2/4 and the same as 1/2. So that is equivalent. So 3.5 because we go through all of our whole numbers of 3, integers of 3. What other fractions do you find equivalent fractions for? Well, you can find equivalent fractions for this one and this one. This one being 1/4 and this one being 3/4. They're the easiest ones, but you could find equivalent fractions for all of them if you kept going up. If you weren't simplifying, you could say, oh, well, they're all equivalent to 16ths and they're all equivalent to 32s. Any number in the 8 times table they could be equivalent to on the bottom, just making sure you do the same to the top so that you keep the fraction the same. And that's the way to think about it. And our final one, number 6. I'm thinking of a number sequence, and the first and fourth are consecutive integers. So I've got 3 in between, which means there's 4 jumps. So you go from, you've got the number here, 1 and 2, and it's the first and fourth. So 1, 2, 3, 4. We've got 1 jump, 2 jumps, 3 jumps. So they're in thirds. And the easiest way to do it is to draw it out, and you'd see it that way. There we go. Hopefully that was all right. Obviously, if you have any questions, we will go through it in the live session if we need to. We're going to do a little bit more on sequencing anyway, but just remember, it all ties into our equivalent fractions and our mixed numbers and improper fractions. Goodbye, and I'll see you in the next video.